Okay, so today we're looking at Chapter 3, Section 4, Solving Exponential and Log Equations. Today we're going to primarily focus on just solving the exponential equations. There are two methods. Okay. First, you can change the bases to be the same. We'll practice those first. And then the other method is to use the inverse, which is log on both sides. Just like if it was 2x plus 3 equals 7 and you wanted to solve for x, you would use the inverse of adding 3, which would be subtracting 3 to both sides. Okay, so let's look at some change of base. Well, in A here, the bases are exactly the same. We don't have to worry about changing them. So what we can do is set the exponents equal to each other. 2x equal 4, therefore x equal 2. Same thing in B. The bases are already the same. So I can set the exponents equal to each other. Now, when we come down to C here and D, it's a little different. The bases right now are currently not the same. Since they're not the same, can I change 32 to a base of 2? Yes. 32 is equal to the 5th. Therefore, x is equal to 5. Okay. So in C, I only had to change one side's base. In D, I cannot change 8 to a base of 4, because it goes 4, 16. But I can change both of those to a base of 2. 4 is 2 squared. 8 is 2 cubed. Notice the 2 cubed, the cube is outside the parentheses of the original exponent. Now I can say my equations, 6x, 2 times 3x is 6x, distribute equals 3x plus 3. Now solve. Subtract 3x from both sides, divide by 3. Now we're done. And you can check that. 4 to the third, 64. 8 squared, 64. I substituted 1 in. Okay. Now, what happens when we cannot change the base? We have to use the inverse. So, you can't change the base, or even if you don't see it, then using the inverse equals all the time, works all the time, which is the log. The other important thing to remember is that the exponential needs to be by itself. In other words, you can't have 2 to the x power and then plus or minus something on the other side. You need 2 to the x, which we'll get to that in a little bit. Okay, so in this first one, log, the base of the exponential is 6. So what I need to do to both sides is the inverse with the same base. Then use the inverse log with same base. Okay, with the same base. So what is the base? It's 6. So I'm going to do log base 6. Well, if I do log base 6 on one side, I have to do log base 6 on the other side. Same thing if you're adding or subtracting. Like I have to add 3 to this side, or subtract 7 to this side. Okay, so this is my property then. So the left side is equal to 2x. So x is equal to log base 6 of 21 divided by 2. Now to enter that into your calculator, you have to do a change of base. Log 21 divided by log 6 equal divide by 2. You get approximately 0.85. If it says to round to the nearest 10 thousandths, well, I'm going to the hundredths. Okay. So in B here, log, as far as I know, that's not 3 to any power. So I'm not going to even attempt that. So I'm going to use, here's my base of my exponential. So I'm going to take log base 3 on both sides. Okay, so here's my identity, my property. So this is x plus 4. Now I'm going to subtract 4, but what I'm going to remember to do is I'm going to put it out here in front so that I don't have the temptation to take 101 minus 4, because you can't do that. This is a number. This is a number in and of itself. So I cannot take and subtract 4 from this 101. And this will give me approximately 0.201. Let's do a couple more. Again, can't change the base. So I'm going to take the log base 5 of both sides. So that's going to equal 2x. So here's my exact answer. Oops, wrote right through the base 5. To enter it in your calculator, you do log 120 divided by log 5 equal divide by 2. And that will give you your decimal approximation. You have to use change of base on that. Okay, so D is different. Remember I said up on the previous slide that you have to have the exponential by itself. This is the exponential. So I need to subtract 4 from both sides. Now, do I have the exponential by itself? Yes, I do. So now I'm going to use log base 7. So here we go. There's that. So this left side is 5x plus 3. I'm going to have to subtract 3 from both sides. Now I'm going to have to divide both sides by 5. So there's my exact answer. For me, I put in the calculator the change of base, log base 168, divide by log 7, minus 3, divide by 5. And you get approximately okay. So you get approximately a negative 0.073. On the next example, we're looking again at getting the exponential by itself. Here's my exponential. So I'm going to have to divide both sides by 3. and I'll get 2 to the x equal 14. 42 divided by 3 is 14. Now I'm going to take the log base 2 of both sides because I can't change 14 to a base 2. So I do log 2, 2 to the x, log base 2, 14. So that's what x equals. Okay, there's my property, my identity. Put my change of base in my calculator, log base 14 divided by log base 2. On B, this is the one where people go, what? I don't understand, because it's base E. So I need to take log base E on both sides. Well, what's log base E? It's just the natural log. So if I take the natural log of e to the x, there's my identity. But I have to do natural log on both sides. Here's my identity, so this side equals x. Put that natural log 72 in my calculator, and I'm going to get approximately 4.277. Same thing. Again, it's e to the x, so I have to use log base e, which is natural log. My identity. So x is approximately 2.565. Well, what about d? Well, d, the bases are the same, so I'm just going to say negative x is equal to 5x plus 6. Solve for x. Negative 6x equals 6. X equals negative 1. Exact same process, except for it's a base e. Still have to get the exponential alone. Here is my exponential. So step 1, add 3 to both sides. Step 2, divide by 4. Now I can take the natural log of both sides. And I get 2x, because here's my property, or identity. Now I'm going to take and divide both sides by 2. I'm going to move up here. And that will give me approximately 0.112. So again, I need to get e to the x by itself. Step 1, subtract 5 from both sides. Step 2, divide both sides by negative 3. What does x have to be equal to? X has to be equal to 1. Because e to the x, I can change 1 to base e, which is e to the 0. So therefore, it's wrong. X equals 0. Because e to the x, I can change 1 to base e, which is e to the 0. So x will equal 0.